How will Alaska coastal communities be impacted by rising sea levels? More than a third of coastal Alaska structures may be at risk of flooding by 2100. A new analysis of flood exposure shows many residential buildings at risk as sea levels rise. Hello friends, Jim here. And as global sea levels rise, infrastructure in coastal Alaska communities is at greater risk from flooding, like this airport runway on Barter Island. In the fall of 2016, an unusually strong storm hit the coastal native village of Kipnuk, Alaska, causing ocean water to flood into the community. The storm surge inundated the lowland area where Raina Paul and her family live while they evacuate to the town school on four-wheelers, ATVs, right? A wave slammed into the boardwalk they were driving on, and Paul's nephew, who was 8 years old at the time, started floating away. She, quick thinking, grabbed him and got him to safety. The result of all that was cleanup and repairs took months. Four-wheelers were found floating in a nearby lake. Anything that had been secured before the flood was scattered around town. And this is the lady, Raina Paul, and that's her nephew. 8 years on after that incident. As climate change continues to spur sea level rise, increase hurricane intensity, mapping possible future flooding is crucial. A new study published in Scientific Reports used community accounts of past floods to show how sea level rise is likely to make future floods worse. The work adds to scientists' understanding of how climate change could affect Alaska's coastal communities as part of a broader effort to improve flood modeling in the state. The data in the new study are really important context for flood planning, said Richard Buzzard, a geologist at the U.S. Geological Survey, lead author on the new research. Buzzard completed the work as a doctoral student at the University of Alaska Fairbanks. Models of future flooding are checked or validated with observations of past flood frequency and severity. Flood modelers can use the record high flood elevation in the community as a proxy for that information. But in rural, coastal Alaskan communities, much of this kind of historical data exists not in a central database, but in the memories and records of community members, elders, etc. Remote coastal communities in Alaska where climate change is acutely felt and rapid changes are observed are often forgotten or underappreciated, said Nora Neminsky, a geologist with the Alaska Department of Natural Resources. Coastal Hazards Program. She was not involved in this study. Flooding can be especially devastating for these tiny communities, which may have limited resources to repair damage. And not to mention that they're isolated, so it is difficult to bring in material to effect repairs. To obtain historical data necessary to improve flood modeling, researchers gathered spoken or written accounts, photographs, and videos from residents going back to 1887. Some of the records were gathered in interviews between Buzzard and community members knowledgeable about flood history. There actually is a department within the library system of UAF that handles archival material. So you can find information down there. A lot of it you'll find are the memories or interviews with the elders and stuff, but there are photographs, some data. So there is an archival department located at the University of Alaska Fairbanks library system. The collection of records called the Flood History Database continues to be updated by scientists from the state of Alaska, USGS, NOAA, NWS, National Weather Service. The records present the unique methods we need to fill in the data gap. Well, do what you can, right? So, yeah, the written accounts, photographs, videos, right? Talking to folks who were knowledgeable about flood history. So, the new study, the researchers used these historical accounts to estimate the current and future flood exposures. They compared record flooding to topography and the locations of buildings in 46 communities under two scenarios, 0.5 meter and 1 meter. So basically 1.6 feet, 3.3 feet of sea level rise by 2100. NOAA estimates that global sea level will rise between 0.3 meter, a foot, and 2 meters, 6.6 feet, by 2100. The team found, it could be more, that's a conservative estimate. The team found that currently 22% of structures in coastal Alaskan communities, that's 1 in 5, 1 in 4, are located within the record high floodplain, putting them at risk of flood damage. Under the 0.5 meter scenario, that number rose to 30%, but on the 1.0 meter scenario, the proportion of structures at risk grew to 37%. In each scenario, more than half of the structures at risk from flooding were residential. Raina Paul said she's always concerned about flooding in Kipnuk and is starting to notice more frequent flood events each year. Now, before we take a look at this image here, let's continue on, and then I have something to explain about how structures are usually built in these areas. The authors noted that the flood risk is a function of geopolitical and colonial forces too. According to a 2022 report from the U.S. Government Accountability Office, indigenous communities are often located in coastal areas because that's where the federal government built schools that the indigenous children were mandated to attend. Decisions about where to build didn't necessarily consider flood hazards. We'll just put you over here and forget about it, right? Small rural communities face systemic obstacles to obtaining federal assistance to address flood exposure due to population size thresholds. These are low population communities, sometimes less than 100 folks, or just a couple of hundred, really very small. These are low population communities, and that has been a disadvantage. They could have a high proportion of exposure to flooding, but they might not be prioritized as highly, might not be made a priority to get them aid to help them recover. So the new model is a step in the right direction and hoping to better understand what might happen and to bring awareness to the situation. The data will ultimately be used for community-specific assessments of flood-related hazards, such as erosion or property damage. Such assessments help communities like Kipnuk develop plans to mitigate flood hazards. They help us better prepare for natural disasters. So Buzz is part of a team working to adapt a widely used USGS flood model, Coastal Storm Modeling System, or COSMOS, for use in Alaska. Arctic environments such as coastal Alaska require a different modeling approach than the original COSMOS uses because sea level rise also interacts with factors such as sea ice or the lack thereof. And when you don't have the sea ice, you then have wave action, wind action, right? And you have storm activity pounding the crap out of the coast, and oftentimes you lose chunks of the coast into the ocean. So, record flood category, purple square is major. You can see a whole bunch of major ones here. Right. A purple triangular one is moderate, such as down here. And here's Kipnuk, by the way, right there. These the gray regions or study jurisdiction. Minor is a white triangle pointed down, and then a circle, excuse me, a circle is no damage. I need to get the illusions going out this way. This is your road system for Alaska. Notice there are no roads out here. No roads. The only way you get to these places here is by plane or boat. Summertime, you get around in ATVs. Wintertime, you get around in snow machines. And here's Russia. I can see Russia from... Anyway. Chukchi Sea, Arctic Ocean, right? Beaufort Sea, right? Utqiagvik, formerly known as Barrow. Utqiagvik. The most northern point on the North American continent. So, this is a quick overview of the road system. This road here goes to Prudhoe Bay. It's actually the longest road in Alaska, called the Hall Road, or the Elliott, actually the Dalton Highway. Elliott Highway is elsewhere. This road goes to Manly Hot Springs. This is the Elliott Highway here. So the Elliott Highway, this is Fairbanks. Elliott Highway leaves Fairbanks and bangs that left-hand turn to Manly. It continues as the Dalton Highway or the Hall Road. This goes out to Circle. It used to be called Circle because people thought they were on the Arctic Circle. But because of the way the sunlight is bent through the atmosphere, it's actually a little south of the Arctic. Arctic Circle is about a little further up here. And so this goes down to Anchorage. This is the Parks Highway. Okay. This is the Richardson Highway. This is the Glen Allen Highway that connects, from Anchorage over to, towards the Valdez area. This is Valdez down, by the way. So the Richardson continues down to Valdez. This is the Alaska Highway. I think it's still a gravel road. It's really some of the most gorgeous scenery in the state. And then you've got, this is the Alaska Highway going towards, the Yukon Territory and stuff like that. And then you got some roads going out to Chicken and into Canada as well. But this is the Alaska Highway. Not very extensive. So these are the coastal communities that are affected. Now, a lot of these places, especially when you get, this is the Nome area. This is Kotzebue, by the way. You get into, here's Nome, Koyuk, Shaktoolik. Right? All the places I've been to a lot of these places. Emonic. You get these places here. A lot of it is permafrost. And when you build houses, you build them post and beam or on stilts. So you can see how a flood can easily just knock the structures right off what passes for a foundation. So with the loss of sea ice and more sea storms and rising sea levels, these communities are at risk. So, there are a number of coastal communities worldwide. Maldives, for example, places in Indonesia, or just coastal cities, New Orleans, New York, right? Any coastal city. They're at the risk of damage from the state of Florida, right? They're at risk at damage from rising sea levels. And it's going to happen. It is happening. We're seeing it now. The 2-meter projection by 2100 could very well be a low ball estimate. Time will tell. So, more sobering news. We'll talk soon.